Good evening, everyone. My name is Jyoti Sharma, and this session will be from 7 to 9. And this is week 10. Okay, thank you, Venkateshwara, for responding. Okay, so this is week 10, and we will cover the content what has been taught in week 10 only. So let me show you the content that we will cover today. So let me Okay, so this will be from lecture 46 to 50, and this will cover industrial pollution control measures, and among which we have the list. So in last week, we tried to cover sludge management, right? So after primary treatment, secondary treatment, and even after tertiary treatment, we had some sludge that we need to dispose. But based on the characteristics of that sludge, we need to manage it. We also had some processes that we already have discussed. So this was the part of the last week that we covered about this sludge management. Right now, for this week, what we will cover is whatever pollution or whatever wastewater that is we are getting out of some industries. So for example, if it is a sugar industries, or if it is a distilleries, or if it is a tannery, or let's say it's a paper industries, so what kind of pollution it will generate, the first thing. If it is, let's say, wastewater, then how we can treat that? Obviously treatment would be basically that primary, secondary, and tertiary. But based on what kind of industries we are focusing on, based on that, we have little specialized tactics that we will use so that we can treat wastewater, let's say if we are getting out of this sugar industries. So but before going to one by one on these industries, sugar to petroleum, we first have to see emission control, effluent control, then solid waste management, noise control, and some SOPs, and even checklist. So before going to industries one by one, we have to cover uh, these bulletin points, right? So first we will cover these bulletin points, then we will go to sugar industries. Again, the interesting part is that we also have some flow chart that will tell you, for example, how we can manufacture the sugar. Because until or unless you do not know how to manufacture the sugar, you will not able to tell like what kind of wastewater you will get, what kind of impurities your wastewater will have. To get the characteristics of your wastewater, and for the particular treatment of that wastewater, you need to know the process which is happening to, let's say, to manufacture the sugar. So we will see how we can manufacture the sugar, how we can manufacture the alcohol, or how we can create the leather, or how we can create the paper, or for the petroleum. And at each step, how this wastewater or some waste product will be generated, we will talk about that, and we will also talk how we can treat that. Okay, so but before that, we have to cover this six bulletin points. So let's start with MCQs. Again, you people are very encouraged to speak, to communicate, and to give me the answer, wrong or right. It doesn't matter, but your participation is highly encouraged. Okay, so the first point is, or the first question is, uh, we do have two type of treatment. The one is STP, or you can say ST, and another is ET. So this is ET. And for that, we use treatment plant, that is ETP and STP. And you have to tell me what is the difference between sewage treatment and effluent treatment. But before that, you have to understand what do you mean by sewage, what do you mean by effluent, right? So we have four options here. Sewage treatment mainly deals with domestic wastewater, while effluent treatment mainly deals with industrial wastewater. Sewage treatment involves removal of heavy metals, while effluent treatment focuses only on organic matters. Both sewage and effluent treatment are identical processes with no difference in source water. Effluent treatment is always less complex than sewage treatment, and I think I got a answer. You people gave me a answer. Yes, so you both gave me a answer. So yes, the answer is A only. So whenever we are talking about sewage treatment, so mostly we are talking about municipal, and in that municipal we have domestic wastewater and the wastewater that is generated from small shops or industries only. But if we are talking about affluent, then it is mostly from big industries that is manufacturing something, right? So let me show you even the difference between this. So you know that the uh, wastewater will come from domestic or municipal source, that will come under sewage treatment, and from industrial source then it will be come under affluent treatment. Main source may be toilet, kitchens, bathroom, laundry, storm water runoff. But here we have some industrial processes. We also have some chemical plants, textile, pharma, tanneries. So if we are getting wastewater from these industrial processes, then that will come under affluent, right? Then type of pollutant that we may have, mostly in the sewage treatment we will have the organic waste. But here in because it is coming from industries, so it may be chemical, it may be dye, it may be organic. So for example oil industries, but it may have heavy metals and some toxic substances as well. And we have different processes, treatment processes, but this treatment processes is just based on what industry we are targeting at, right? So based on that we will have different step to treat that effluent, right? And here mostly it is biodegradable. So whatever organic matter or whatever matter that have in the wastewater, that will be mostly biodegradable. But here it can be hazardous and it can be non biodegradable. So I think this is clear what's the difference between sewage treatment and effluent treatment, right? Okay, so this is just to show you that we can have different treatment processes, and that treatment processes will have to be very specific if there is some industry and that industry is releasing some wastewater. Okay, so the next question is we have industries, we have classified industries into three categories: red, green, orange. So you have to tell me in which type of industry is the affluent treatment plant configuration relatively less complex. And you have option: red category industries, green and orange, both red and green, and none of the above. Okay, so I got answer B from both of you. So obviously, if we have color like red, green, and orange, you always know that red is the dangerous one, then green is the safest one, and sorry, green is the safest one, and in between we have the orange. So if some industry has been categorized into green and orange, it means it is giving you a less hazardous or less pollutant or less contaminated wastewater. Okay, so based on that, even the ETP, that is effluent treatment plant configuration, will also be less complex. Let me show what industries will come under red, what industry will come under green, and what will come under orange. So yes, the answer was B only. So okay, just see here. Whenever we have green industry, the potential for the pollution is negligible or very low. And examples are, it can be small workshop, bakeries, assembly units, small plant, food processes without effluent discharge. If it is if that industry will come under orange, then it will emit moderate pollution, and industries may be dairy processing, small textile, dyeing, food and beverages, paper, and auto service station and all. And if that industry will come under red category, that means it is emitting very high or severe pollution. And example may be a large chemical industries, tanneries, pharmaceutical, pulp and paper mills, refineries, fertilizer and distilleries. So what we will discuss in next slide, mostly red industries that has been categorized into red. So we will talk about this one by one, right? And complexity of ETP, right? Because it has very negligible pollution, then that means minimum treatment is required. If it is a orange, then moderate ETP required. But if it is a complex, then a lot of steps that we have to follow, primary, secondary, tertiary, and even after that also we have to follow a lot of steps so that hazardous contaminants are not will no run on this river and all, right? Okay. So the next question is, which statement about organic removal from wastewater are correct? Only biological method are always sufficient. Electrochemical can degrade organics. A physiochemical use for toxic organics. Combination depend on wastewater. So let's say if you have wastewater in which you have organic matters, and if you want to remove that organic matter, uh, what different processes you can follow so that you can remove organic matter from wastewater? Any guess? Okay, I'm getting D, but I'm scared that D is not the right answer. Yes, so Dia gave me C answer, and I agree with C only because third option is also right. This option is also right. So because biological method we can follow, electrochemical method yes we can follow, biophysical method can also be followed for organic removal, and the combination what kind of method we are having will depend on what type of wastewater we have, right? So these four options are correct, right? So the most appropriate will be 2, 3 and 4. So that's why answer should be C but not D, because all these statements are right. Now let me show you. Okay, as it is discussed in this MCQ only, we have techniques. The techniques to remove organic from the wastewater, and we have three techniques: biological, electrochemical, and physiochemical. So the next questions will be, what will come under this biological? What will come under this electrochemical? And what will come under this physiochemicals? Okay, so the question will be based on subcategories that will come under biological, electrochemical and physiochemical. But before that, this is just the differentiation between these three terminology. If this is a biological, this is very clear that we will use microorganism to degrade the organic matter. If we are using electrochemical, it means we are having electrical current that will drive the oxidation or reduction. Physiochemical means physical and chemical processes that will destroy or that will remove that organic matter. These are some examples that I wanted to show you for, and we already have discussed about it, right? So if it is a biological, then activated sludge, biofilm reactor, anaerobic digestion, we already have talked about this. Then if it is the electrochemical, then electrocoagulation, oxidation, phenols. So these are the example of biological, electrochemical and physiochemical. right? And different method, uh, we can apply different method based on different type of wastewater. So for example, if we do have biodegradable organic matter into the wastewater, then biological method is more appropriate. Okay, if we do have toxic organics and that is not degradable, and even if that is giving you color, then that means we can use electrochemical method to remove the organic matter from the wastewater. If you have dyes or heavy metals within that wastewater, that means the most appropriate method to remove organic matter will be physiochemical. And we do have different advantage, limitations, and common use that you can read later. Just here, just understand the difference between these three. Okay, as I told you, within each categories we have subcategories, and this question is which is not the subcategory of physiochemical method for effluent control in industrial pollution. And we have four options here: adsorption, coagulation, flocculation, reverse osmosis, screening, and grit removal. I'm scared. Everyone is giving me a variety of options. Uh, so I'm getting C, B, C. What do you mean by a physiochemical method? And here it is, C. The thing is, the answer will not be B or C, but it would be D. And why it would be D? Because we are reading right now the physiochemical method to remove the organic matter. If it would be like to remove the dust and all, then it may be that under physiochemical method, screening and grit removal, or even if you want to remove plastic, so that time this should not be the answer. But right now, because we are talking about how we can remove organic matter from wastewater, right? And under this physiochemical method, adsorption is the right one. Coagulation, flocculation, right one. Reverse osmosis is also the part of physiochemical method. But grit and screening method is no doubt a physical method, but this is not to remove the organic matter. So that's how D will be the right answer here. And these are different, you can see. Under physiochemical method, you have evaporation and combustion, chemical, photochemical oxidation, adsorption, coagulation and flocculation, and membrane filtration. So under which you will have reverse osmosis, ultrafiltration, and the nanofiltration. So based on that, that D answer was the right one. And let me give you brief. So evaporation, you know about this evaporation, and even combustion. So evaporation means some VOC. Can you tell me the full form of this VOCs? What is it? What is that? We have some VOCs in the wastewater, and these VOCs are volatile organic. Yes. So this is volatile organic compound. So this volatile organic compound from the wastewater can be removed using evaporation, because they are volatile in nature. If we are doing the combustion, so for example, if we do have glucose, if we do have glucose in the wastewater, so for example, in the sugar industry, we have a lot of sugar in the wastewater, and that sugar is the organic matter. And if you want to remove that, if you have slurry, um, slurry of this glucose, then you can do the combustion, you can burn this, and that will give you CO2 and H2O. So this is how you can also remove organic matter from your wastewater. Then chemical photochemical oxidation, I have one slide to show you that. Then adsorption, for example, we are using activated charcoal where adsorption can be happen. Coagulation and flocculation, though we already have discussed about this, I have next slide to show you coagulation and flocculation. And membrane filtration, I think you know better, because uh, in most of the kitchen right now we have ROs and all, and that is exploiting this membrane filtration technique. So this is your um, electrochemical. So what will happen, so for example, if we do have ozone or something, uh, if we do have hydrogen peroxide, this hydrogen peroxide, using some photocatalyst in the presence of sunlight, will give you the hydroxyl radical, OH minus. And these hydroxyl radicals are a strong oxidizing agent that can oxidize your pesticide, and that can change your pesticide or even any organic matter into CO2 and H2O. So that will come under photochemical reactions and all, right? Then under this we also had this coagulation and flocculation. We already have learned that in coagulation we have some chemicals that we have to add in wastewater, so that these suspended particles that have the negative charge, and because of the repulsion between this negative charge, these are suspended in nature, these are not settling down. And if we do have some coagulant that we will add, so that will neutralize this charge, and this is how it will be settled down. So this is the process of the coagulation. Then if we are moving it slowly, the solution, then what will happen, this will come under the flocculation, mixing slowly, because it will also enhance your settling down the matters, organic matter, let's say. So that's how the impurity will be settled down. So this will come under the flocculation. And these are the part of physiochemical process. Then this is like well known figure that is showing you reverse osmosis and all. So we have some filtration. So if we have raw material may have a lot of contaminants based on the filter size of your membrane, either it is microfilter, ultra filter. So we have pore size. Based on that pore size, we can remove these contaminants easily. For example, we are using in the ROs. So this will also come under physiochemical processes. Okay, so the next process was biological method, right? And you have to tell me which of the following is not a biological method for effluent treatment. And we have four options here: fungal treatment, aerobic treatment, phytoremediation, coagulation, and flocculation. I think this is the easiest one, because in last to last slide only we were discussing about the coagulation and flocculation. Yes, and that coagulation and flocculation was the part of physiochemical method, but it is not the biological one, right? So yes, D answer will be the right, but not C. C is a phyto means plants. So whenever, let's say in the soil, we have some heavy metals, or let's say some organic matters, and we are growing some plants on that soil, so that that plant can take such kind of heavy metals or organic matter, and can store either in root or in stems, or it can vaporize in the atmosphere. So this is how plants can also remediate or plants can also remove the contamination from soil, from atmosphere. So that's how, and this is living, organic, or you can say these are the living things. So this is the part of biological method, right? So that's how C is the biological method. Aerobic treatment, we are using aerobic microorganism, aerobic bacteria. Fungal treatment, we are using some fungus also. For example, in the soil treatment also we can use some fungus. So this will come under the biological method, but coagulation and flocculation is the physiochemical method that we already have discussed. So D answer will be the right one. And here you can see more. So under biological, this will be fungal treatment, aerobic treatment, phytoremediation, microbial fuel cell, and anaerobic digestion. I think we already have discussed all of these in last week. Okay. Which of the following statement is correct regarding solid waste management and noise control in industries? So industries are not just giving you the wastewater, but it can pollute the air, and it can also can give you the noise pollution, right? So you have to tell me the right answer. So here are the options. Industrial solid waste is identical to municipal solid waste and can be disposed by normal MSW procedures. Solid waste often contain hazardous material and require special treatment and disposal. Noise from industrial activities does not require any control measure. Residential waste and industrial waste are managed in exactly the same way. I think MC, these options are very easy, in which you can find odd one out, right? And this one odd one out is already you have given me, Diya, uh, Venkateshwara, you both gave me a B answer. Then yes, this is odd one out answer, because industrial solid waste is very different from your municipal solid waste, because industrial may have hazardous material, it can give you noise pollution, so we also have to control this noise pollution also. And if you have heard about mufflers and all, so we have to use mufflers, you can read about this, to control the noise as well that is generated from the industries. Okay, now we are moving to some SOPs that we have to follow, what should be in industrial premises, right? So which of the following is an example housekeeping measure in industrial premises? Good housekeeping and preventive maintenance, open discharge of untreated effluent, dumping hazard waste with municipal garbage, ignoring fugitive emission during inspection. So again, yes, you people gave me answer A, and this one is right answer, because discharge in open, this is not the uh, right way to control the pollution. Dumping is also not the right, and ignoring during inspection, so this is also not the right. So the right only is good housekeeping and preventive maintenance. And we have a list. Let me show you the list. So this is the list, what should be under this industrial premises. So the first is floor area become dirty, wet, oily and unsafe. So this we have to keep, this we have to clean, right? So good housekeeping is essential to maintain environment health of the workers. Regular inspection is also required. Preventive maintenance is essential to avoid accident. Proper documentation, proper painting, and standby arrangement should also be there. So these are some SOP that we need to follow. These are also some checkpoint that we have to see. uh, we should know what production capacity some industry has. It should not be overloaded, right? So production capacity should be as per what a government authority has given the access. Okay. And consumption of material as per approved ratio, production of emission and effluent as per standard with respect to quantity and quality. You have to update process flow sheet. Then you have to segregate the waste and pre-treatment prior to final treatment. So these are something that we have to check. So these are the checkpoints so that we can ensure a healthy environment. Okay, so this was very theoretical in nature. So till now what we have learned is this one, right? We have learned till now about this emission control, effluent control, solid waste management, noise control, SOP, and checkpoint to ensure the environment. So we have covered this part. Now, what we will do, we will first cover sugar industry, what kind of pollution it will generate, and how we can treat that, and even how we can manufacture the sugar, right? So the next step is pollution control in sugar industry. So based on that, we have some MCQs. But before that, let me tell you how we can manufacture the sugar, right? So this is very easy. First, we have to weigh the can. Then we have to crush this sugar cane. Then there is the one process that is juice defecation and the clarification, because it will have some impurity and different colors that we have to clarify. Then we have juice sulfitation. So this is bleaching part. So because that sugarcane juice has some different color, because but we need transparent sugar, right? So based on that, we need some bleaching agent. So the one of bleaching agent is your sulfur dioxide and all. So this process will be juice sulfitation. Then we will boil that syrup, and then we will centrifuge, and then we will get some sugar. But whenever we are crushing or whenever we are milling it, so some of the waste will be generated. So for example, baggage will be generated from here. If whenever we will do the clarification, no doubt clear liquid will go on for the further manufacture of sugar. But along with that, there will be some mud that we have to remove, and that mud will give you some uh, challenge for the disposal. Okay. And here also centrifuging, whenever we will do the centrifuging, there will be molasses, and again we have to dispose it somehow, or we have to use it. So what we are getting from that is there are a lot of steps. At each step there may be some wastage, or there may be some contamination, and that we have to and that is challenging for the treatment, and that we have to see in the next slides. Okay, this is just the replication of what we already have seen. So we already have seen, we will extract the juice, then we will heat the juice, then there is the juice sulfitation, and then again we will reheat it. So these are the different steps to manufacture the sugar. uh, then we will have clear juice, we will have the evaporation, again we will have the syrup sulfitation, then we will use vacuum pans, and then we will do the crystallization, and then only we will get this dry grading and of these sugar crystals, right? So these are the processes. I'm not okay. So okay, So now we have some MCQs on this. Which of the following is not a typical source of wastewater in the sugar industry? Cooling tower overflow, process wastewater from mill, boiling house, and boilers, high COD wastewater from evaporative tube cleaning, rainwater harvesting overflow. I think odd one out option is very easy to find out. Yes. So the answer is D. We already have seen, like, we have to boil the syrup. If we are boiling the syrup, then after that we have to use some coolant to cool the water, to cool that syrup uh, at the fast pace. So we have to use some cooling water, and that cooling water is again very challenging to dispose. Then we have some wastewater from mill, boiling house, and boiler. We already have discussed the steps. Then high COD wastewater from evaporator tube cleaning. So as there was one step of the evaporation of the clean syrup, and the cleaning of that will also give you high COD. But this one is odd one out, so that's how this is not the right one, a source of wastewater in sugar industry. So that's how D is the right answer. Okay. Uh, in the sugar industry, ETP, which unit directly follows the equalization tank? Oil and grease separator, primary clarifier, flocculator, microsettler, and aeration chamber. So for the treatment, this is just like primary to secondary treatment to tertiary treatment. So this is something we do have equalization tank where we have to mix. So like different wastewater may have a different proportion of organic matter. Let's say we have to mix them together or simultaneously, so that we have so another process will be easier for us to perform on that wastewater. So that will come under equalization tank. But before that, what unit we had, that we have to connect that unit to equalization tank? Let me see the answers. Okay, I got C answer from you. And yes, so this is the right one. So this is the flow chart, how we will move on. So we have the wastewater from the sugar industry that we have to first mix. Then we also have oil and grease separator. We will separate oil and grease. Then we have equalization tank, and then we will have the flocculator and microsettler. After that we will have the primary clarifier, then aeration chamber, secondary clarifier, carbon and sand filter. Then we will use the lagoons, and whatever water we will have, purified water, that we will use in the irrigation. And here we will have some, like in these steps, primary clarifier, secondary clarifier, and settler, uh, because here we have to remove some sludge, either from this one or this one or this one. And that sludge, we have to dry that sludge into the drying bed, so that we can either we can use it or we can landfill, sanitary landfill it, right? Okay. Which byproduct from sugar industry ETP process is commonly diverted to sludge drying beds? Treated effluent from lagoons, sludge from primary and secondary clarifier, cooling tower blowdown, filtered water from sand filters. What do you think? What is the right answer? Which process, whatever waste that you will have, that would be diverted to the sludge drying bed? Yes, Venkateshwara, Dia. Okay, both gave me a B answer. So yes, as we already have discussed, right here, that whenever there will be the sludge, so sludge will be produced after this flocculation and microsettler. Sludge will be produced after primary clarifier, and sludge will be produced after this one. So whenever we will have sludge, that sludge will be diverted to drying beds. And we already have understood in the last week, I think, what do you mean by drying bed, and what are different method by which we can manage this sludge. We had a lot of techniques that we have discussed, and one of that technique is we have drying beds. On that beds we can spread this sludge, and this is how this sludge can be dewatered and can be formed into solid. Because it is we already have learned that sludge is a slurry have water and some suspended particles and all. And after drying bad, we will have the solid form of this sludge. That would be easier for the management. Okay, the next question is, high COD wastewater from tube cleaning in a sugar industry is directed to. So whenever we will clean some tubes in the sugar industry, because that tubes will have some sugar, and that sugar will give you the high COD wastewater, right? Whenever we are cleaning, that sugar plus water will give you high COD wastewater, that we have to divert to where? Aeration chamber directly, oil and grease separation tank, equalization tank with regulated flow, lagoon bypass. Okay, let me see the answers. Tia gave me C. Yes, so I also agree with this. So C is the right answer. See, oil and grease is not giving you high COD, and oil and grease is very different from different organic matters. No doubt, oil and grease are also the part of organic matter, but here, if we have high this COD wastewater, this wastewater is different from oil and grease. So this will not be the right answer. Lagoon is the last like second last or third last step, so this is again not the right. Aeration chamber can be the one where we can cultivate the microorganism and then we can degrade, but before that we have to mix this all water together, and that will come under this equalization tank. So that's how C answer will be the right one. Okay. So the next question is, in the sugar industry ATP, what is the role of microsettler after lime treatment in the reactor? Removal of oil and grease, reduction of BOD and COD by microbes, settling of suspended solid or sludge, neutralization of wastewater pH. Why we have one step, that step have microsettler? What kind of work that microsettler will do in sugar industry? Okay, so I'm getting D and C answer, and C answer is the right, because see, from the name only you can find out this is settler, so that will settle down the suspended solid or sludge. uh, After it doesn't mean that after lime treatment lime will give you some different pH, and for the neutralization we need some chemicals, right? But not the microsettlers. So that's how C is the right answer, but not D. Okay. How is high COD wastewater from evaporator tube cleaning managed in the sugar industry ATP? Directly sent to aeration tank for microbial treatment, stored in the hazardous tank and released intermittently to equalization tank, mixed with oil and grease separator output, discharged untreated into cooling tower overflow. We already have learned that whatever we will get wastewater from after evaporator tube cleaning, that uh, uh, we have to divert it to the equalization tank, right? And before equalization tank, we may store it into hazardous tank. So that's how B will be the right answer. Yes. In the first aeration tank of sugar industry wastewater treatment, which of the following is correct? So, because we are using the aeration tank, so there must be some residence time. So, you have to tell me the residence time, uh, and you also have to tell me what dissolved oxygen quantity it will have. So we have four options here. Residence time is less than 10 hour with DO 5 to 6 mg per liter. B is residence time is more than 30 hour with DO 1 to 2 mg per liter, and MLSS is 2500 mg per liter. C is the residence time is 5 hours with DO below zero point 0.5 mg per liter, and D's residence time is more than 50 hours with MLSS less than 1000 mg per liter. Let me see the answers. Okay. What do you think? Okay, let me tell you. Here the residence time is yes. So answer is B. Yes. So residence time will be more than 30 hour, where dissolved oxygen will be 1 to 2 mg per liter. Can you tell me the full form of MLSS? We already have learned it in secondary treatment. MLSS. And if it is the irrigation tank, then what does it mean? Why we are using the irrigation tank? Why we are giving air to wastewater? What will happen whenever we will supply the air to the wastewater? Dia gave me a full form, that is mixed liquor suspended solid. Yes. So this is mixed liquor suspended solid. So this is something that we measure of the microorganism. So microorganism we can measure in the form of MLSS. And so in the aeration tank, we give air, we have some microorganisms, and that we can quantify with MLSS, and we have wastewater, right? And this is how we can treat that wastewater. We can have the treatment. So that's how we should have some MLSS concentration also, and that should be near to 2500 mg per liter, and there should be sufficient time, residence time of the microbes, and giving the air to the microbes, so that your high COD wastewater can be degraded. Okay, so that's how B answer is the right one. In the first stage of sulfur, as we have one step, that was the juice uh, sulfitation, something like this. Sulfitation. There is a one step in to manufacture the sugar is the juice sulfitation, that sulfur is used as a bleaching agent by which we can remove the color of uh, can juice into white crystal, right? Into white color, right? So that's how we are using sulfur. And now we have to remove, and that sulfur will be in the wastewater, and we need to remove that sulfur from the wastewater. So now question is based on that. In the first stage of sulfur removal from sugar industry wastewater, addition of calcium hydroxide lead to the formation of what? Sodium hydroxide and calcium sulfate, calcium carbonate and sodium sulfate, calcium chloride and sodium hydroxide, sodium sulfide and calcium hydroxide. Let me see the answer you already have given me. Uh, Dia and Venkateshwara. Okay, both gave me A answer. And yes, I also agree with this A1 that whenever, because we need to remove this sulfur, okay, sulfur from the wastewater. And how we will remove that? We need to add calcium hydroxide, and there will be some reaction in with sulfur to calcium hydroxide, and what it will give you? Sodium hydroxide and calcium sulfate. So this is how we can remove sulfur from the wastewater. So here you can see that sulfur will be in the presence of sodium sulfate. And then we have the calcium hydroxide, and this will give you the calcium sulfate, that is the gypsum, and sodium hydroxide. So this is the first step to remove the sulfur. And we also have second stage or second step to remove the sulfur also, using some reagents. In the second stage of sulfur removal, soluble gypsum is converted to an insoluble compound known as. So in the first step, gypsum is formed, right? And that gypsum we have to convert into some insoluble compound. And what is that compound? Dia gave me a B answer. Yes, Venkatesh Rao also. So yes, B is attringite. So as you have seen here also. So in the second step, sulfur removing reagent, polyelectrolytes will react with the soluble sulfate, mainly gypsum, and it will convert into insoluble calcium alumina sulfate compound, and that are known as yttringite, right? So this is how we can remove sulfur from the wastewater that will be generated in sugar industries. This we have done. Okay. Now we will have some sludge. As I told you, we will get sludge from primary clarifier, from secondary clarifier, and even from microsettlers. But we have to manage that sludge also. So which of the following is correct about sludge management in the sugar industry? Sludge is produced mainly due to nutrient in wastewater. Drying bed require less land area than filter press. Sludge after drying is always disposed of in landfill only. Sludge can be dewatered using filter press or decanter. Dia gave me D answer. Yes. So yes, I also agree with the D answer only. So sludge is produced mainly due to nutrient. No, sludge is mainly produced due to sugar quantity that we have in the sugar industry. Drying bed require large area. Then filter press. We already have discussed how we can have different techniques to dewater or to manage the sludge. Uh, Sludge after drying is always disposed of in landfills. No, uh, landfill is the last option, but we can also incinerate, or even we can use it as a manure, something like that. We can use this sludge in different useful forms. And sludge can be dewatered using filter press or decanter. Yes. So the technique how we can remove water from the sludge to make it drier. So we can use filter press, and we can also use decanter. So here just see, we can to de-water the sludge or to dry it, we can use drying beds, we can use filter press, or we can use decanter. And just see here, drying bed require more land area, and we can use this dry sludge as manure. Okay, so this part is also done. Now we are moving to distilleries. So we have next industry that is known as the distillery industry. Now most of these questions will be based on this one. Okay. Which of the following raw material is commonly used in distilleries for producing alcoholic beverages? Sugarcane molasses, crude oil, iron ore, limestone. I think this is answer is very quick to answer it. Okay, so you, Dia and Venkatesha, both gave me A answer. Then yes, it is sugarcane molasses. So whenever we will have the sugarcane, uh, we will extract the juice, and the remaining part will be known as the molasses. This molasses can be used to produce the alcohol and even for the paper, to manufacture the paper. Okay, and it molasses have different, it can be used as we can spread it in farmland also, so that moisture can't be removed from the soil. So a lot of uses that we can have of this molasses, that is remained after juice extraction, right? But the thing is, what do you mean by this distilleries? So I have a few slides to give you overview what do you mean by this distilleries, right? So distilleries can produce alcoholic beverages, but what exactly is the distilleries, right? So let me show you. Firstly, just see that uh, if we are producing alcohol and mainly ethanol, that ethanol can be produced by coarse grain, by non-agricultural things, by molasses, by sugar beets, by juice, or by wheat. Okay, so this is right now we are talking about. Now, what is distillery? So, distillery is an industrial unit where two processes, that is very important. The one is fermentation will happen, and second, distillation process will happen. Fermentation and distillation will produce alcoholic beverages or some industrial alcohol that we need. For example, ethanol or rectified spirit. We will talk about this rectified spirit. Don't worry about this. So distilleries means we will have the fermentation, we will have the distillation, and this is how either we can produce alcoholic beverages or some alcohol that we need in the industries, for example ethanol, for example for the fuel. Okay, then we need some raw material for the fermentation, right? And that raw material can be sugar based, for example sugarcane molasses. It can be starch based, because for the fermentation we need some uh, fungi, you can say. That fungi will give you the fermentation, or you can use bacterias. But that bacteria and that fungi will grow only on the substrate that will give them the energy, right? So that energy will come from starch or from sugar or from like different nutrients that fungi or bacteria should have for the fermentation. So that's how raw material will be either sugar based or starch based or other agro product, for example potato, fruits, cassava and sorghum and all. Okay, so we will have raw material either based on sugar or starch or some other agro products. So based on that we will have some fermentation. So the steps are, we have to ferment this sugar into alcohol, the first thing. Then we have to distillation. So this distillation, alcohol separated and concentrated using distillation columns, and that will produce rectified spirit, neutral alcohol, beverages grade alcohol. So it means this will concentrate and this will separate different alcohol type, right? And then we will have maturation, so in which we will like in the case of, let's say, whiskey, rum or brandy aged in wooden cask for flavor development. So this will come under the maturation. So right now you know what do you mean by distilleries, right? Okay. And what would be the product? We already have discussed that product may be alcoholic beverages, maybe industrial, uh, maybe industrial alcohol, but there may be some side product that we have to take care, because right now we are studying how different industries is giving you different uh, waste thing or waste water. Okay, so uh, the byproduct of distilleries will be molasses spent wash that will have high BOD or COD wastewater. It will give you CO2 gas. It will give you sludge as well, and it can also give you potash or protein rich residue. And this is concern for us, how we can dispose this, how we can treat this into the atmosphere or into even if we are giving it as a runoff in the river, then it should be treated. So these are the major environmental concern that we have from distilleries. Okay, now question will be based on some processes and then how we can manage it. What is the approximate range of fermentable sugar content in canned juice compared to molasses from sugar industries? So the question is to get the fermentable sugar content that we will get from either from cane juice or from molasses from the sugar industries. Let me see. Dia gave me B answer. So yes, answer is B. That from sugar cane, fermentable sugar content will be just 3 to 15%, but molasses that we will get from the sugar industry, here the fermentable sugar content will be 40 to 45%. Okay. Now, because as I told you, we will have fermentation. So that fermentation will convert your sugar, sucrose, into glucose and fructose. But which enzyme is present in some yeast that is responsible for this conversion? So we have zymase, amylase, invertase, maltase. Let me see. I got C answer and C answer. Yes. So yes, this is invertase enzyme that is present in the yeast, and that will give you the fermentation. And that fermentation will convert sucrose, a sugar, into glucose and fructose. So this is you can see. So we have sugar cane and water that will give you glucose or fructose, and then you have this glucose. That glucose will be changed into ethanol, so this is alcohol that we need, and CO2, so this will be the byproduct, right? Okay. In the fermentation process of molasses, which is the correct equation for conversion of glucose? We already have discussed in last slide only. So that will give you alcohol, right? And so this is not the right answer because this is not giving you alcohol, but this is giving you carbon dioxide also. But here we need balanced equation. So balanced equation means, let me see the answers that you already have given me. Okay, I got B and A answer. So B answer is the right one because you have to balance. So, for example, here we have C. C is 6, but here it is 2 plus 1. So we have just 3 carbon. So this is not the balanced one. If we have 6 here, then this will give you 4 and this will give you 2. So this is how C will be 6. And this is how you can balance the equations, and you will get to know which one is the correct one, that is for the conversion of glucose to ethanol and CO2. Okay, now we have some terminology that is very much related to this distilleries only. So, which of the following is not a section in molasses based ethanol production flow sheet? So, if we want to produce ethanol from molasses, so what steps we should have to follow that will come under this flow sheet? So fermentation, multi-effect evaporator, incinerator boiler, electrolytic cell for alcohol splitting. Okay, so you both gave me D answer. Yes, so D answer is the right one because we already have the flow sheet, and that flow sheet have some section that is, first we have to store and handle the molasses, then we have to do the fermentation, then we have distillation, then we have multi-effect evaporator. We will talk about this. We also have incinerator boilers and CPU, condensate polishing unit. So this will form the whole flow sheet of the distilleries, right? In molasses fermentation, what is the main purpose of heating dilute molasses media at 55 to 90 degrees Celsius for 30 minutes with hot steam and air purging? We have four options here: to evaporate ethanol, to sterilize or pasteurize the medium, to increase sugar concentration, to directly start yeast propagation. Okay, so I got B answer from Venkateshwara. So yes, so why we are heating the dilute molasses uh, at 85 to 90 degrees Celsius for 30 minutes is that because we want to sterilize or pasteurize the medium. So B is the right answer. Okay, so the thing is, in distilleries, we got to know that the one of the important step was the fermentation, and next step was the distillation. And for the fermentation, we need yeast, we need yeast, and we need some sugar, right? But we also have to grow this yeast. Okay, so that will come under the yeast propagation. Okay, so how? So first we have to propagate the yeast, then there will be the fermentation. Okay, so this question is, in the yeast propagation process of molasses fermentation, when is yeast culture transferred aseptically from lab vessel to the pre fermenter? When specific gravity of the vessel content increase above normal, when specific gravity of vessel content reduce immediately after cooling without monitoring, only after distillation is complete. So when this yeast culture that we created of the yeast, that we have transferred to the pre-fermenter. But when we will get to know that this is the right time that we need to transfer this yeast culture to pre-fermenter? Let me see the answer. Okay, so you both gave me a B answer, but my next question is, uh, okay, so when specific gravity of the vessel content reduces, but why? Why this is the case? Why we are taking into consideration the specific gravity of the vessel, and based on that, we will get to know, okay, this is the right time to convert to transfer this yeast culture to fermentation tank. So how we will get to know after this, after measuring the specific gravity only? There is some logic why we are using specific gravity to transfer. So okay, first you just see the flow chart, then I will tell you. So first, we did the pasteurization. Water specific gravity changes. Specific gravity is very much related to how much sugar content we have, and based on that sugar content, yeast growth will be dependent on. So that's how this specific gravity is important. I think in the next slide I have this explanation. So after this pasteurization, we have to cool it down because we are boiling it kind of. Then we have to transfer this yeast culture to yeast vessel. Then this yeast will grow till specific gravity reduces. This is important step. Yeast will grow till specific gravity reduces, and then we will have the next step. So just see here. Okay. So during growth, this is important. During growth, yeast cell consume the sugar present in the medium. So specific gravity is the measure of density of liquid compared to water. In fermentation, it reflects sugar concentration, and whenever so yeast is consuming the sugar, right? Yeast is consuming the sugar. So whenever they will consume, so this means the specific gravity will reduce. It means sugar content will be reduced, and this is the sign that yeast cell has been grown. This is the indication that yeast cell has been grown up, because it already have taken up the sugar, and this is how it has reduced the specific gravity, right? So this will be the sign that this is the right time that we can transfer it to the fermentation tank, right? Because yeast has been grown up, and this we got based on the specific gravity. I think next also have. So this is at the start, molasses medium will have high sugar concentration. It means high specific gravity. As yeast consumes sugar that will convert into ethanol and water, the sugar concentration decreases, and that will reduce this gravity to the down value. So reduction in Sg means yeast has successfully propagated, producing enough biomass to move to the pre-fermenter, and thus this is the transferring point that is identified by the drop in specific gravity. Okay. In molasses fermentation, the concentration of fermentable sugar is adjusted using what? Plate heat exchanger, static molasses diluter, degasifying column, cooling tower. How we can adjust the concentration of fermentable sugar? Okay, so I got A answer, I got B answer. But I agree with the B only. So we will use static molasses diluter. So this is kind of one machine that will help to adjust the concentration of uh, fermentable sugar. So that's how B is the right one. So just see here, we have molasses that is stored into the storage tank. We will weigh that uh, molasses. Then we do have static molasses diluter that mix this sugar concentration with the water to make some specific concentration, and then we will have the fermenter, right? And this one plate heat exchanger is using to maintain the temperature, but to not maintain the concentration. This is next step, you can see. Okay, what is the typical alcohol concentration of fermented wash before it is sent to distillation? 2 to 5%, 10 to 12.5%, 20 to 25%, 30 to 35%. See, before it is sent to distillation, so what is the concentration of alcohol that we got? So I got B answer from both of you. Um, so this is nearly 10 to 12.5% is just the concentration that we will get, but after distillation, because distillation will concentrate and will separate also different type of alcohol. So but before that we have just 10 to 12.5% volume by volume alcohol concentration. Okay, so the next is in the multi pressure rectifier distillation system. So we have a specific type of distillation system, and that is known as MPR, multi pressure rectifier. Rectified spirit is obtained at what approximate concentration? So we have 70 to 75%, 85 to 90%, 95%, 99.9%. So Venkateshwar already given me the answer. So this is B. Here it is B. Okay. So but this is, yes, so Dia gave me a right answer. But before that, you have to understand what do you mean by this rectified spirit. Okay, and then how much concentration that we will get of this rectified spirit. Distillation system, you know about this, but we have a very specific distillation system that is known as the multi-pressure rectifier distillation system. So first we will know what do you mean by this rectified spirit, and then this is how why this concentration is very high. So rectified spirit, this is also known as neutral spirit or extra neutral alcohol, ENA. This is very high concentrated alcohol that is obtained by repetitive distillation, and that's why this is multi pressure rectifier system. And here we have 95 volume by volume ethanol that we will have. And why it is not 100%? Because ethanol forms some azeotrope with water also. That's how this is giving you near to 95 ethanol. Okay, the next is, then if we have very high concentrated alcohol, then how, where we can use this? So we can use this in pharmaceutical and medicinal preparation. We can also use it as industrial solvent, in beverages industry, also in chemical, and even in fuel or energy industry we can use this rectified spirit. Okay, so rectified spirit is nothing but this is very high concentrated alcohol, near to 95%, and that we can use for multi-purpose. Okay, so just see here. Uh, we have some analyzer column, and then we will get some rectified spirit or molecular and we will have then molecular C by which we can filter and all. But just see that this is the product that we will get. This is the product, and the side product will be fusel oil, spent wash, and then a lot of things that we will discuss in the next. But just keep in mind that product is rectified spirit, but byproduct are spent wash and even fossil fusel oil. And we need to treat, or whenever we will have some treatment processes, then we have to take care of this spent wash and fusel oil. Okay, which of the following is the byproduct separated in the rectifier cum exhaust column during distillation? I think this is, I already have discussed recently only. Molasses, fissile oil, baggage, or press mud. So Dia gave me answer B. Yes, I already have discussed here, right? So we will get rectified spirit, but along with that we will have this fusel oil that will be as the byproduct that we need to, and that would be in the wastewater, and we have to remove such kind of oil from the wastewater so that we can reuse the water, right? So that's how this B answer will be the right answer. But what do you mean by this fusel? So again, this is the byproduct of alcoholic distillation, and this is the mixture of higher alcohol formed during fermentation in small amount along with the ethanol. So this is not the exact. So most of the time we need the ethanol. Okay, but it is the mixture of higher alcohol. So for example, amyl, butyl, or propyl alcohol. So that we need to remove from the wastewater. And these are the alcohol um, which make this fusel oil. We already know that this will form after this rectifier come exhaust column. And the characteristic of this is that it has a strong unpleasant odor, and based on that only the name is given fusel. And it is very insoluble or partially soluble in water, and we can also use this after refining, but this will be the part of wastewater as well. Okay, as I told you, one was the fusel oil, but another was the spent wash. That will be the side byproduct. So in multi effect evaporator plant of distillery, spent wash is concentrated up to what range of bricks? 20 to 25, 40 to 45, 58 to 60 degree breaks, 70 to 75 breaks. And my next question will be, what do you mean by bricks? Okay, so the thing is, you both gave me the answer C, and that answer is obviously correct answer. But I want to know, what do you mean by this bricks? Any answer? What is bricks? You gave me right answer, right? So what do you mean by bricks? Okay. So I have some explanation. You can read about this. So Brix is the measure of sugar concentration in the solution. And this will be expressed as the gram of sucrose per 100 gram of solution. So 10 degree Brix means 10 gram of sugar in 100 gram of solution. Okay. And now, because spent wash from distillery is very dilute. Okay, so very dilute means it is like we have the wastewater, and wastewater have sugar, and that is very diluted. It means we have huge amount of wastewater that will have a very very small amount of sugar. So we can't manage it like properly, because if we do have higher concentration of sugar in in a small amount of water, or a small amount of solution, then we can manage it easily, because the volume will be lesser, the density will be higher, and we can use. So the thing is, using this multi effect evaporators, we will evaporate that solution so that the concentration can be high of the sugar. So this will reach up to 58 to 60-degree Brix. Okay. Then this concentration slurry, this is also known as slope. Whenever we will concentrate that uh, diluted solution, then it will be known as the concentrated slurry, that will also known as the slope. And we can burn it in incinerator boiler so that we can generate the energy. Okay, so this is, so the thing is, whenever we have let's say molasses, some of this after fermentation will give you the ethanol, but we will also have some sugar in the solution that will be wasted. So first we have to, using evaporator, we have to concentrate it, and then after that, whenever we will have thick slurry, then we can use this incineration. So this is how uh, we can uh, manage we can manage the wash, spent wash that we have, right? Okay. What is the purpose of feeding concentrated spent wash slope into incinerator boiler along with baggage or coal? In the next slide only, we already have discussed. Whenever we will have higher concentration of this, and we are putting it into incinerator boiler. So what is the purpose? Why we are putting that slope into incinerator boilers? To generate the electricity. Yes. So I got B answer from Dia. So yes, we have to generate the electricity if we have concentrated spent wash, and if we do have incinerator boilers. So we can generate the energy by burning these things along with coal and along with baggage also. Uh, the purpose of to show is that what we will get spent wash. So as I told you, spent wash is something solution that have some sugar, and if it has more sugar, it means the BOD COD will be very higher, oxygen demand will be very higher. So it needs to be uh, so we need water, treated water. But the thing is, we have to remove this COD and BOD out of this solution. How we can do this, we will learn this, right? Which type of wastewater in distillery typically have the highest COD, BOD and color? Cooling tower overflow, spent wash, bottling plant wastewater, and boiler blowdown. We already have learned that spent wash will have high concentration of BOD, COD, and color because it has high concentration of sugar. So yes, you both gave me a B answer. So I also agree with this one. So again, just see what do you mean by this spent wash. So this is liquid waste, or you can say byproduct, that will be generated after distillation of fermented molasses. Uh, and this is kind of residue that will left after alcohol has been separated out. And just see the BOD and COD value. Very high organic loading, it will have near to 40,000 to 50,000 mg per liter, right? And it will also have high salt and dissolved solid as well. And that's how this will give you some environmental concern. So and that's how we have to treat the solution of this spent wash before discharging into any river. Okay, spent wash also have dark brown color. This is presence of melanoins formed through which reaction? Photosynthesis, Maillard reaction, sponification, neutralization reaction. So that spent wash have dark brown color, and that is because of melanoidins, and that is formed. You have to tell me which reaction. Okay, so you both gave me B. Yes, so this reaction is known as Maillard reaction. I think this is not important. Okay. We also have learnt about slope, right? In distilleries, concentrated spent wash, that is slope from MEE, is primarily sent to cooling tower, blow down system, incinerator boilers, RO reject storage tank, lagoons without treatment. We already have learned, yes, Dia gave me right answer. So we already have learned, then whenever we will have high concentrated sugar solution as a spent wash or the byproduct, that we can burn in incinerator and we can generate the electricity in the presence of coal and bagasse also. So this is how B answer is the right one. I think this may be last question of this distilleries. So which of the following wastewater stream are treated in the condensate polishing unit? Cooling tower, blow down only, RO reject and floor washing, spent lees and process condensate, fermenter washing only. So Dia gave me C. Venkateshwar also gave me C. So yes, whenever we have condensate polishing unit where we can treat spent lees and process condensate, that we will have, that we can treat under this consent CPU. So this is, I think you already have seen this table. So different techniques we have for different type of byproduct that we will have. Boiler ash that we will have, see, after incinerator ash will also produce, right? So boiler ash, or this is different type of ash actually. So boiler ash in sugar distillery unit contain about 14 to 22% potash and is commonly mixed with which material to produce biomanure? So whenever we are burning molasses, let's say, that will give you high potash concentration. So we have to mix that potash with something to produce biomanure. So we have to mix it with what? Okay, so Sagar gave me B answer, that we have to mix it with press mud and filtrate sludge so that we can produce biomanure. Yes, so this is the right answer, that we have to make the mixture of potash and press mud and filtrate sludge so that we can use it as the biomanure. In the evaporation route for spent wash treatment, concentrated slope is primarily utilized for direct irrigation, production of molasses, cogeneration in boiler with bagasse, other fuel, and cooling tower operation. Dia gave me C, Sagar also gave me C. Yes, we already have learned that whenever we will have the concentrated spent wash, or you can say slope, then we can use it in the incinerator to burn it out and to generate the electricity. So we have to use it for cogeneration of electricity in boiler along with other fuel. So you people gave me C answer, and that one is right one. This we already have learned. There is no need. Okay, so we have covered different checkpoints, then pollution control in sugar industry and pollution control in distilleries. Now we have three more industries. Pollution control in tannery. Uh, Most of the question will be based on this tannery only, and very few question, I think 5 to 10 question maximum, will be on pulp and paper and petroleum refinery. So most of the question will be on tannery, because tannery uh, involves multiple step, and at multiple step you will have the wastewater will be generated at multiple step, right? So this is how it generates huge amount of wastewater. Tannery, so tannery is to produce the leather. So to produce the leather, a lot of wastewater is generated, and that's how more focus will be on tanneries. And very few question, I think 5 6 question I think I have on the remaining two industries. So okay, so we have different step how we can manufacture this leather. So now in the remaining time we will learn how we can manufacture the leather, or let's say a leather belt we have. So how we can manufacture that leather, we have multiple steps, so we have to understand that step also. So okay, the question is, what is the main purpose of tanning animal skin in the tanneries? Why we need tanning? And we have option here: to make skin lighter in weight, to permanently alter protein structure making skin durable and resistance to decomposition, to increase natural moisture content, to reduce the thickness of hides only. So Diya and Venkateshwar both gave me B option. Yes. So why we do tanning? Uh, yes. So the tanning, so that we can alter the protein structure, and whenever we will alter that protein structure, it means we are making that skin or hide very durable to use it for the long time. Which of the following statement about tanning is correct? Uh, Traditional tanning uses chromium salt derived from tree bark. Chrome tanning was developed in 1800 and uses chromium salt instead of natural tannins. Natural tannins are synthetic chemical discovered in 20th century. Skins do not require soaking or dehairing before tanning. So Dia gave me a B answer, and Sagar also gave me a B answer. So yes, so for the tanning, we people mostly use chromium salt right now in place of natural. Yes, so B answer is the right answer. Okay, so these are the huge steps that we have to follow to manufacture a leather. So just see from the left hand side. First, we have raw hide or skin. Then we will soak it. Most of the question will be based on these processes only. So you need to see the sequence of these processes. So first we will soak that, then we will do the liming, then we have the fleshing, de-liming, batting, degreasing, pickling, chrome tanning, and that's how we will get the wet blues. Then we have next step: smying, splitting, shaving, trimming, wet back, rechrome, neutralization. This will be the next step. The next step will be retanning, dyeing, fat liquoring, fixation, settling out, drying, crust, and then staking, milling, buffling, spraying, embossing, ironing, and that's how we will get the finished leather. So these are the different steps. And as I told you, at each step we will have the wastewater, and that wastewater will have very high BOD and COD. Okay, so step by step we will see what do you mean by, let's say, soaking, or let's say liming or batting, and then what kind of wastage that will be produced in each of these steps. We will learn about this. Okay, so what is the typical duration for soaking raw salted hides in tank before further processing? 2 to 4 hours, 6 to 8 hours, about 12 hours, 36 hours. I got C answer from Dia. Venkateshwara gave me D answer, and answer is C actually. So it is about 12 hours that we have to give to soak this hide or skin in the tank before further processing. So this is the time is near to 12 hours. So this is overnight time. Okay, so the next, so you we talked about the soaking. Okay, the next process is liming. So in the liming process of hide, lime and sodium sulfate are used primarily to. Why we are using lime, potassium sulfide? So we have four options: preserve hide for storage, remove hair and unwanted proteins, add color to the hide, increase the thickness of hides. Okay, so Diya and Venkateshwara both gave me B answer. So yes, so why we are using lime and sodium sulfide is that we have to remove hair and even unwanted protein from the hide. So that's how we are having this process that is known as the liming process. Okay, next process is fleshing. What is the main objective of fleshing in leather processing? To add shine to the hides, to remove adhering flesh from the inner side of hide, to neutralize chemical used in liming, to soften hide using ammonium salt. Okay, so Tia and Venkateshwara both gave me a B answer. So yes, Sagar also gave me B. So yes, so why we are using this fleshing? Because inner side of the hide we also have some flesh, and that flesh of the animal we need to remove so that we can have solid hide. So that's how we will have the fleshing. So we are fleshing out the inner side of the hide. Okay, next step is deliming and the betting process. Which chemicals are commonly added to the hides before treatment in the drums in deliming and the betting process? So we have four options: lime and sodium sulfide, ammonium salt, sodium bisulfite, bait powder, common salt, sodium formate, and sulfuric acid, chromium salt and vegetable tanning, only sodium chloride and water. So let me see. I got C answer and B answer and B. Okay. So the answer will be B. So in deliming and betting process, we are using chemical, for example, ammonium salt, sodium bisulfite, bait powder, common salt, sodium formate, and sulfuric acid. The thing to observe is that how much chemical we are using, and we are treating our hide with such kind of chemical. And after treating the hide will be extracted out, hide will go on for the next step. But this chemical will give you the waste water, or will give you a lot of hazardous material that we have to treat before discharge or before disposing it into the atmosphere. So just see, uh, at each step, at each step we just need the hide, but the remaining part, or the byproduct, at each step we will get some byproduct. And for that, uh, and each byproduct will have some water, and that water will have high concentration of either chemicals or organic matter, for example flash, or some different things we may have. Okay. Okay, the another process is chrome tanning. So after chrome tanning, hide processed and preserved in the drum are commonly called wet white, wet blue, crushed leather, and rawhide. So Dia and Venkateshwara both give me B answer. So yes, uh, because tanning is giving you more lifetime of the leather. Okay, so this is how you can process and preserve it in the drum, and that will be known as the wet blue. Okay, so we have different type of leather, right? A different color we may give to the leather. Here the question is, which type of leather is dyed without pigment so that natural grain pattern remain visible? Tia already has given me B option. So yes, B option is the right one. That this is aniline leather, where we do not uh, we just dye the leather but without pigment, so that whatever natural grain pattern that we have on that leather, that should be visible to us. So that would be known as the aniline leather. Another process is fat liquoring. So what is the primary purpose of this process in the leather processing? So to color the leather uniformity, to introduce oil that maintain flexibility and prevent leather from becoming hard on drying, to neutralize chrome salt to polish the leather surface. Okay, so you both gave me a B answer. So this is something like why we are giving the oil to the leather, and the main purpose to give the oil to the leather is so that we can maintain the flexibility, and so it is not it doesn't become hard on drying. So yes, B is the right answer. In leather finishing, okay, now we are going to the end. In leather finishing, finishing agent are mainly used to reduce the tensile strength of leather, impart fullness and attractive appearance to leather, make leather fiber rigid and immovable, remove all traces of fat, liquoring oils. Venkateshwara gave me A answer. Why? Uh, okay, Dia gave me B answer. So the answer will be B. Uh, Finishing agents are used to impart the fullness and to give the attractive appearance to the leather, but it is not used to reduce the tensile strength. Okay, so B answer is the right one. So, okay, so these are different steps that we tried to cover. Obviously, some of them we couldn't cover, but a lot of steps we covered. Okay, now the thing is, each step is giving you some wastewater or some hazardous things. Okay, so just see in between, uh, the column is giving you the step: soaking, liming, flashing, deliming, pickling, chrome tanning. And in the left hand side, it is giving you what kind of things we need for that process. So for example, for the soaking, we need water, we need biocide, and we also need some enzyme. For the liming, we need water, we need sodium sulfide, and we need lime. For flashing, we need water and some mechanical flashing that we can do. For the liming, we need water, ammonium salt, betting enzymes. Okay. And because we are using such kind of things, then we will have some waste water as the byproduct. So after soaking, we will get the waste water and high TDS, SS, we will have suspended solid, we also have the chlorides. Then after liming, we will have the wastewater that will have high pH, high BOD, high COD, high SS, and even sulfur within that wastewater. After flashing, we will have wastewater with high pH, high BOD, COD, SS, and sulfur. So just see that at each step, we are getting the wastewater. So just imagine how much wastewater will be generated. And in that wastewater, uh, different pH, different nutrient, different BOD, COD amount will vary. And to treat that is very challenging for us. So sometime some organization or NGOs are protesting against leather because this is the part of cruelty. Uh, I don't want to debate on this much, but uh, people argue that this consists of cruelty plus generation of wastewater. Then removal of this weather industry can give you a lot of better options. Okay, so these are the few different steps, and that will give you wastewater. Okay, next question is approximately how much water is consumed for processing 1 kg of hide in a tannery? 3 kg, 10 kg, 20 kg, 30 kg. Okay, so I got D answer from Venkateshwara and Dia. So yes, it is 30 kg of water will be consumed to process the 1 kg of hide in a tannery. Okay, so because as I told you, in the wastewater, we will have high BOD, high COD, we may have some nutrients, we may have some chemicals. And we already have learned if there is high BOD and COD, secondary treatment is more useful. And in the green color and in near to red color, you can see we are using biological treatment. So we are using conventional legume system, anaerobic legume, aeration tank, fully aerobic system, combined treatment with UASB. So we can use this so that we can remove high BOD from the wastewater. Okay. Now, because as there was the chrome that we use, right? So we will have wastewater, and that wastewater will have the high concentration of chrome. So we have to remove that chrome from the wastewater. So in chrome treatment, the recommended dose of MgO from chrome bearing wastewater is, so to remove the chrome, we are using magnesium oxide. So, but how much concentration, how much dose we have to give? So, Dia and Venkateshwara both gave me answer B. So, yes, this is 15 to 25 kg uh, per 6 kl. So, you need to tell me what do you mean by this kl. This you can search later. Okay. Now the recovered chrome, because we need some chrome, right, that we already have recovered from the wastewater using some processes, that we have to store in the tank that is made up of what? Stainless steel, concrete, FRP, HDPE, aluminium. Okay, so you both gave me C answer. Can you tell me the full form of this? FRP and HDPE? What is the full form of FRP and HDPE? And why we are storing chrome into that kind of container only? Okay, so you both gave me a full form of HDPE, that is high density polyethylene. Yes, and FRP is fiberglass reinforced plastic. And this material, we why we are selecting this, because these are non-corrosive, chemical resistance, and durable. So these are a very suitable material to store the recovered chrome liquor safely. Okay. After chrome treatment in the tannery, so the supernatant should be sent to distillation unit, equalization tank for non-chrome wastewater, sludge drying bed, reverse osmosis unit. Okay, so Dia gave me B answer. So yes, Venkatesh also gave me B. So the supernatant, after removing the chrome, so that wastewater should go to the equalization tank, and that wastewater right now doesn't have the chrome because chrome has been recovered. Which of the following coagulant is most frequently used in tannery effluent treatment? Okay, so after equalization tank, there is a coagulation, flocculation, secondary treatment, and all. So, can you tell me the chemical or coagulant that we will use in tannery effluent treatment? So we have sodium chloride and sodium carbonate, alum, iron sulfate and iron chloride, urea and ammonium nitrate, zinc sulfate and potassium permanganate. I think you already have given me B answer. Yes, Venkateshwara has given me B answer. Yes, so we will use coagulants. That coagulant may be alum, iron sulfate, or iron chloride. Uh, uh, to remove this chrome, we used MgO, as in last to last MCQ. We learned that. But this chrome bearing wastewater will react with the MgO and will form what? Chromium oxide, hydroxide, metal, chromium chloride. Venkateshwara gave me a B answer to this. So yes, they also gave me B. So yes, whenever there will be the reaction of MgO with uh, chrome bearing wastewater, then this will give you the chromium hydroxide. Why is MgO considered appropriate as an alkali for chrome recovery in tanneries? Why we are using MgO? It reduces the need for sulfuric acid entirely. It is flexible in design, simple in operation, and has low investment cost. It prevents the formation of sludge in clarifier. It directly converts chromium hydroxide into metallic chromium. You both gave me a B answer, and this is exactly the right answer, that it is flexible in design, simple in operation, and has low investment cost. Okay, so the next question is, in tannery effluent treatment, the supernatant from primary clarifier is directed to. So after primary treatment, in which for what process we will divert our wastewater for the further treatment? Sludge drying bed, aeration tank for biological treatment, tertiary treatment directly, online monitoring system. Yes. So everyone gave me a right answer, that after equalization, after primary clarifier, we have to divert this wastewater to aeration tank, where we can have this biological treatment. Okay, what is the purpose of sludge drying bed in non-chrome effluent treatment process? So we already have learned that the purpose of drying bed. Yes, so the purpose of drying bed is so to withdraw and to dry generated sludge, so with remaining water that we can we recycle to ETP. Yes, B is the right answer. Main concern with Tannery sludge is that it still may have high chromium content, near to 40% of anthropogenic chromium pollution. Yes. Uh, then, why incineration of Tannery sludge considered problematic? Because it can generate hazardous ash. So that's how even in incineration of sludge is also problematic. Okay, so we have covered distilleries, tanneries, and then we have sludge and paper. I think I have 4 or 5 questions on that. And petroleum, I have one question. So let me just. Uh, what is the source of fiber for the paper production? And this is wood fiber. We already know that plant. We use plant-based fiber that can give you the paper production. This is the process how we can manufacture the paper. And then what kind of waste it will produce. So these are just to show you the slide and how we can treat the wastewater that will come from the pulp and paper industry. Very much similar. We will have the arrow because fiber is biodegradable in nature, so we can use biological treatment for this. Uh, this bleaching is giving you the highest pollution intensity in the wastewater in this pulp and paper industry. Then this is how much wastewater does a paper mill with a recovery unit generate per ton of paper produced. This is near to 70 meter cube. This is question on copper smelter, and I think this is done. We have 2 more question of this smelter and all. And this is the last question. I think this question you can access that I will upload like this PPT. I will upload in that Excel sheet, so you can avail this PPT and you can also explore the remaining that 5 6 questions. So thank you so much uh, to be very patient, from 7 to 9. And if you have any query, you can let me know. You can anytime write me on my email whenever you have any problem. And now we have just 2 weeks left, and then this syllabus will be covered. Thank you so much. Have nice food and good night. So good night.